Hello again. So today we're going to continue with the arithmetic sequence section. We're going to do arithmetic and we're going to do geometric sequence and series. All right. Definition of a sequence is it's the order in which the number appears. That is very important. That means that depending on the type of sequence you have, you could have numbers, you could have shapes, but in this case we're specifically working with numbers. So, and they may follow specific patterns. So let's look at a few examples. For example, A, here we notice that this sequence is going up by 1. So basically to get from one term to the next term, you're adding 1. So, and that continues, and then you can go ahead and write the next 20, 30 terms. Simple as that. The next one, in this case, this pattern, it looks like that you're subtracting 2 to get a succeeding term. Okay. Next one, this is subtracting 2. And next one, it could be that we are, in this case, notice that being squared. So 1 squared is 1. This one would be 2 squared. 9. 3 squared, 16, 4 squared, and so forth and so on. So the value, each term is being squared. This one is being multiplied by 2 in this case. So these are all examples, and many more you can come up with, examples of sequence. Now the idea is that can we come up with a general term that kind of gives us some kind of a equation where we can find the value of any specific term. Now notice that a couple of things when you're writing. Let's start out with the let's do the 1, 2, 3, 4. So this is called the first term. So this is the second term, and so forth and so on. Okay, and at the end, when I say Tn, that is the last term, and the way we say that's Tn, T sub n, and n is the number of the term number. Okay, so and how many terms are in this sequence depending on how many values are showing up in that sequence. Okay, so each of these are called the terms, right? So you could have a sequence with the 50 terms in it. You could have sequence that are 4 million terms in it. So let's write general term for some of these sequences examples on top. Okay, so for example for A, all right, so by the way, the notation for general term is T sub n. Okay, and that's basically n. So if you want to find the fourth term, n is 4. When n is 4, what do we get? We will get 4 in the sequence right here. That's the 4. Okay. How about the next one? Look at C, Tn. We want to find 1, 4, 9, 16, 25. Notice that being squared. So that's basically n squared. Whatever the value of the term is squared. So for example, if you want to find the third term in a sequence, so n will be 3, so it will be 3 squared, and 3 squared is 9, and 3 squared 9, which is right here. Great. So look at D. Know that when you start with the 2 in a base, and then the exponent of n, and based on that you're going to get each of the term that you want. For example, if you want to find the fourth term of the sequence, so that means n is 4, so you go 2 to the 4. Is that 16? Yes, it is 16. And sure enough, you notice that this 16 and this 16, that's the fourth term of the sequence. So fourth term is 16. Okay, simple as that. So let's talk about a specific sequence. We call that arithmetic sequence. And in arithmetic sequence, notice that the pattern that shows up for each successive term is that by adding or subtracting, doesn't matter, if the same constant value. So notice that in order to get to next term, we just keep adding 2, and this can be going on forever, really, and we can keep doing that. So the constant term that we are adding, we call that the common difference. That means between 4 and 2, there's 2 difference. 6 and 4, there's 2 difference. That's called common difference. It doesn't change, okay? And then we go through, and then we can set up a formula for it, a pattern, a relation that we can come up with any term in a sequence. So notice that the first term, we're going to call that T1, and T1 also we're going to call that A, okay? And of course we have the first term, second terms, third, fourth, fifth, and then this can actually end up, the last term is Tn, that's your last term. Okay, so the way we write this is this. To get the general form, we have to start with the first term A, okay? But then to get the next term, we have to add, we must add the common difference, and the common difference in this case, the name for the common difference, we call that D, just to make it simple, okay? And whenever we want to find the next term, we always include D, but here's the catch. The catch is that we can't just, whatever the N is, multiplied by D, we can get that because the first term is already included. So we have to always subtract 1 term, and then you're going to get the second term, or each successive term. So for example, let's look at the 2, 4, 6, 8, 10 in this case. So if I want to find the first term, A is 2 plus, and N is 1, so that would be 1 minus 1, and then you multiply it by 2. But this part right here, that is 0. Okay, so that doesn't change. So T1 is 2. Great. This is why we have this N included with the -1 inside the bracket. That -1 takes care of their first term so that we can get A back, okay? And that's what that is. So this is the general form of any arithmetic sequence that you can come up with. You can use that to come up the number of the terms. You can use that to solve for any of the variable that is missing based on the sequence. So here's an example. Suppose we have this sequence, and it's an arithmetic sequence, and we want to find the 15th term of the sequence. So let's write up what is it we do know. We know A, the first term, 6. We know D. What is D? We know that that's plus 4. That's 4. And we know N. N is the 15 right here. Okay? We don't know T15, the value of T15. All right, we're going to use the formula. Let's plug numbers in. So T15 equals, let's start with 6 plus, we want the 15th term, so 15 minus 1, and you multiply that by 4. Let's do the math. So here you go. The T15, the 15th term of the sequence is 62. Simple as that. Okay, just go through and make sure that you do the BEDMAS correctly, and that is it. So this question, okay, so which term is 102? All right, so let's go ahead and do that. So Tn equals 102, which is equal to 6 plus, we don't know what N is, but we do know the D. So we'll plug it in. Now we're going to do the math. So we're solving basically for N, and to do that you're going to expand, and you'll end up getting 100 equals to 4N. Therefore, N is 25. So the 25th term is 102. Okay, simple as that. All right, let's look at another example. This is a little bit more intense example, but the idea is the same. So in this case, we want to find the sequence, but the 3rd term and the 10th term is given to us. All right, so we have to go through and write up the general term for each of these term numbers. So T3 is 8. What is that? So let's start with T3, which is equal to 8, and then we have to write A. We don't know, find what they are. So let's write up the formula. 8 equals to A plus N. We do know N is 3. So n we do know, that's 3, and then it's 1, and then times d. Okay, that's we do know. All right, so that means, and then we can do the same thing for t10. So n we do know, n we do know, n we know that is n is 3 and n is 10. Those two values we do know, times d. All right, now we have two equations with two unknown. Let's rewrite these. So we have 8 equals, in this case we got a plus 2d, so that's your equation number 1, and equation number 2 is 4.5 equals to a plus 9d. All right, this is a system of equations, two variables, two unknowns. We need to solve that, and you have to use your grade 10 math to solve that. So basically it's an elimination. In this case, you're basically subtracting the second equation from the first equation. You eliminate a, so the a will be gone, nothing will be there, so that's gone, and then you subtract, you get 3.5 equals to negative 7d. D will be negative 0.5. You take the d, plug it back into the first one of the equations, either first one or second one, and you find what a is. Okay, so the first term is 9. So we go through that, it seems 9, and now we can write the sequence. So what is the sequence? The sequence starts with 9, and it goes down by 0.5 each time, and here is the sequence. That is it.